Hello little friends, this is Manish Khandelwal and the name of this channel is Brainy Builders. I am posting presentations suitable for school going children on this channel. The presentation I am going to post today is suitable for class 10th science students. As the students may be knowing that there is only one textbook pertaining to science in class 10th. This book contains chapters related to physics, chemistry and biology. I shall initially post the presentations related to chapters on physics and then on chemistry. One thing more, all my presentations shall be both in English and Hindi language. The presentation which I am going to post today is already posted in Hindi language. There is one chapter in physics by the name light. It covers both reflection and refraction. Reflection is mainly explained through spherical mirrors and refraction is explained through lenses. On this presentation, I shall discuss only mirrors. First, we will have some discussions on mirrors and then we will solve few numericals to understand the subject better. So let's start. Let's understand few properties of light. The first is light travels in straight. It doesn't travel in zigzag fashion. It travels in straight line. Second is the speed of the light is 3 into 10 to the power 8 meter per second. Actually, this speed is in either air or in vacuum. So this is 3 into 10 to the power 8 meter per second, which is equivalent to around 30,000 kilometers per second. So this is the speed of the light. Third property is that light travels as particles and waves. Then if light falls on opaque surface, it casts shadow on the other side. This again proves that light travels in straight line. And the last property is that no medium is required for light to travel. As I said before also that it can travel in vacuum also. So light doesn't need any medium to travel. There are three types of mirrors. One is plane mirror, second is concave mirror, and the third is convex mirror. One surface of the mirror is nicely polished, and this polished surface acts as the reflecting surface of the mirror. As can be seen, the reflecting surface of the plane mirror is flat, whereas the reflecting surfaces of the concave and convex mirror is either bent inwards or bulge outside. The mirror in which the surface is bent inside is called concave mirror, and if the reflecting surface of the mirror is bulging outside like this, then it is called convex mirror. Both convex and concave mirror are called spherical mirrors also. We can read more details about the mirrors in subsequent slides. So let us understand few nomenclature with respect to concave and convex mirrors. So as it is written here, concave and convex mirrors are made out of glass sphere. So this is a glass sphere. If you cut the sphere from these 2 points and polish the inside surface nicely, then you will get concave mirror. Similarly, if you cut this glass sphere from these 2 points and polish outside surface, then you will get convex mirror. The center point of the mirror is called pole. So this is the center point and this is the center point. So pole is at the reflecting surface and it is denoted by this red small circle. Here this is the pole, this is the pole. Also this is the principal axis. So the principal axis also touches the mirror at pole. This is principal axis, this is pole. So this is denoted with pole. We have just taken this out from here. This is a concave mirror. This is its pole. Then the radius of the circle from which the mirror is made out. For example, this mirror is made out of this circle, this glass sphere. So the center of this sphere will be called the center of curvature, and it is denoted by C. And the distance between P and C, pole and center of curvature, is called radius of curvature, R. So C is center of curvature is a point, whereas PC, radius of curvature, is a distance. And if we divide this radius of curvature by 2, then we get the focus of the mirror. Very important. So 1 is the pole. We can understand once again. Pole is the half point of this circle. Then the center of the circle from which the mirror is made out, the center is called the center of curvature. The distance between the pole and the center point is called the radius of curvature, and focus of the mirror is half of radius of curvature. And this whole AB is called the aperture of mirror. What is reflection? Very simple. Properties of light rays bouncing back after hitting the polished surface of the mirror is called reflection. So this is the incident ray which is hitting the polished surface of the mirror and it is bouncing back. This is called reflected ray. This is called incident ray. So there are two laws of reflection. One is angle of incidence theta I, this one, is equal to angle of reflection theta r. So how to draw this angle theta I? What is this? So if you draw a perpendicular from the point where the incident ray is hitting the surface, then the angle between that normal and incident ray is called angle of incidence. Let me once again explain it. If you draw a perpendicular from the point where the incident ray is hitting the mirror, then the angle between that normal and incident ray is called the angle of incidence. And the angle between the reflected ray and normal is called angle of reflection. And as per the law of reflection, both these angles are same. If this is 10 degrees, then this is also 10 degrees. And second law is that incident ray, reflected ray and the normal, all three shall be in one plane. So these are the two laws of reflection. One is the angle of incidence is equal to angle of reflection, and second is the incident ray, the reflected ray and the normal, all three shall be in same plane. Let us understand the types of images. We need to keep one thing in mind, that the image of an object shall be formed where two or more reflected rays are meeting or appear to be meeting. There are two types of images. One is real image and second is virtual image. Let's understand the properties of each image. First, real image. First property is that real image shall be formed where two or more reflected rays are actually meeting. Then this real image shall always be inverted, as can be seen here. This shall always be inverted. And the third property is that the real image can be projected on screen. Now let's come to the virtual image. Virtual image actually is formed where two or more reflected rays are appear to be meeting. In real, the reflected rays are actually meeting, whereas in virtual image, the reflected rays are appear to be meeting. The second property is that it shall be erect, as can be seen here. And the third is that it cannot be projected on screen. So these are the two types of real images. Once again, real image is formed when two reflected rays are actually meeting, whereas virtual image is formed where two or more reflected rays are appear to be meeting. Real image is always inverted, you can see it here, whereas the virtual image is always erect. It is normally shown with dotted lines. Then real image can be projected on screen, whereas virtual image cannot be projected on screen. Let us see how an image is formed on a plane mirror. Suppose this is a plane mirror and this is its axis. An object is placed on the axis as shown with this red arrow, and say the distance between the angle and the object is 4.6 centimeter. An incident ray shall be falling from object on this point of the mirror. Say this is the incident ray. From the same point, there will be a reflected ray. This is the reflected ray. Now, if you draw a perpendicular from a point where the incident ray has struck, it shall follow the axis. So this is the perpendicular. Now, as we have studied before also, the angle between perpendicular and the incident ray is angle of incidence. So this is angle of incidence and denoted by theta I. Similarly, the angle between the perpendicular and the reflected ray shall be the angle of reflection. So this theta R is angle of reflection, and theta I shall be equal to the theta R. Another incident ray is falling perpendicularly on the mirror, and needless to say, if any ray is falling on perpendicularly on the mirror, it shall be tracing back. So this is the incident ray, it falls on the mirror and it shall trace back. Now, if you see that this ray, the reflected ray, and this reflected ray shall never meet, because it will go in this direction and this reflected ray will go in this direction. We have studied also that the image shall be formed only when the reflected rays meet. Otherwise, image cannot be formed. Now, what to do? How to do? Now, let us extend the reflected rays. So, we have extended this reflected ray here. Let us extend this reflected ray also. We have found that it has met here. So both these reflected rays have not actually met but appear to be meeting here. Once again, they are not meeting actually but appear to be meeting at this point. So at this point, virtual image shall be formed. So always in plane mirror you will have virtual image forming. And the distance between the plane mirror and the image shall be equal to the distance between plane mirror and object. So these two distances shall be same. If this is 4.6 centimeter, this is also 4.6 centimeter. Also, if the height of the object is 2.5 centimeter, the height of the image shall also be 2.5 centimeters. So what we have seen, that image on the plane mirror, it shall always be virtual and erect, because the reflected rays are not actually meeting, they are appear to be meeting here. So the image shall always be virtual and it shall always be erect. Second is the size shall be equal. The image size shall be equal to the size of the object. Then object and image are at a same distance from mirror. So mirror and object, mirror and image, the distance shall be same. And lastly, it shall be laterally inverted. That means the right hand side of the object shall be appearing it to be left hand side of the image. So that is the laterally inverted. So this is how the image on a plane mirror is formed. Now let's see how the images from a concave mirror is formed. Basically, it depends upon the location of the object. Here the object is shown with red arrow and the image is shown with blue arrow. First stage is when the object is placed at infinity. In this condition, the image shall be formed at the focal point of the mirror. The size shall be point and it shall be real and inverted. That means all the reflected rays shall be meeting at F. The second position is that if the object is between infinity and center of curvature, in this condition, the image shall be formed between center of curvature and focus, between C and F. The size will increase from the previous one, but still it will be lesser than the object, and it shall be real and inverted. The third condition is if the object is at center of curvature, the image shall also be formed at center of curvature. This position is very important. Many times the question comes, where will be the image formed if the object is placed at center of curvature? Then the size also becomes equal now. Size of the image is now equal to the size of the object, and it shall be real and inverted. The fourth condition is if the object is between C and F, then the image shall be formed between infinity and center of curvature. Now here the size has become larger than the object. It is now enlarged and the nature shall be real and inverted. We must have seen here that as the object is moving towards the mirror, the image is moving away from the mirror. When it was at infinity, the image was at focus. When the object came closer, the image got further away from the mirror, and size also has increased. Similarly, then it came to now at center of curvature, the image also moved to center of curvature. Now the size is equal, and here if you further bring it down, now it is further closer to the mirror, then the size has also increased and the distance has also increased. So these are the fourth condition. The fifth condition is when the object is at focus. In this condition, the image shall be formed at infinity. One more interesting thing, in first condition, the object was at infinity, the image was at focus. Now, just reverse. if the object is at focus, the image shall be at infinity. And the last condition is, if the object is between focus and pole, this is the condition. In this case, the reflected rays shall not be meeting actually. So, we shall not be getting real image. In this case, the reflected rays shall appear to be meeting behind the mirror. So the image shall be virtual and erect, and its size shall be enlarged. So these are the 6 conditions. We'll understand these conditions with ray diagrams. Now these are the ray diagram. There are 2 slides here. So this is the first slide. Say this is the concave mirror. This is its principal axis, and of course this is the pole, focus, and the center of curvature. Now if the object is at infinity, one ray, incident ray parallel to the main axis shall fall on the reflected surface of the mirror, and it shall be reflecting, and it shall pass through the focus. So this is one of the property of the concave mirror, that when the incident ray is parallel to the main axis, then it shall always pass through focus after reflection. Or vice versa, if the incident ray is passing through focus, it shall always become parallel to the main axis after reflection. This is another ray parallel to the main axis, and this shall also pass through focus after reflection. We can have 2 more or 3 more rays, that every ray which is parallel to the main axis shall pass through focus after reflection. So the image shall be formed at focus. Now this is the second condition. Again I have put the concave mirror with pole, focus, and center of curvature marked. Now in this condition, the object has come closer. It is now between infinity and center of curvature. Now the one incident ray is parallel to the main axis. It has fallen on the concave mirror. As previously, it shall pass through the focus point. Now the second ray will pass through the center of curvature. It will fall, and this is another property of the ray, that if the incident ray is passing through the center of curvature, it shall reflect, or it shall trace back the incident ray. So it is falling on the mirror through C, through center of curvature, and it shall go back also from this. Now where the reflected rays are meeting here, at this point, one is this reflected ray and another this reflected ray. So they are meeting at this point. So that means our image shall be formed at this point. So image is smaller, it is smaller than the object, it is real and inverted. The third condition, if the object is placed at center of curvature, one ray of course is parallel to the main axis. After reflection, it shall pass through the focus point. Second, again, if the ray, incident ray, passes through focus, then it will become parallel to the main axis. So it has fallen on the mirror, passing through focus point. After reflection, it will become parallel to the main axis. So the reflected rays are meeting at this point. So image will be formed at this point. So this is the image. So if our object is kept at point C at center of curvature, then the image shall always be formed at seeing only, and its size shall be same as the object. It shall be real and inverted. The fourth condition, if the object is between C and F, between focus and center of curvature, then one incident ray shall pass through focus and it will become parallel to the main axis. Then second ray, of course, will pass through the center of curvature. So as we have seen before also, that if it is passing through center of curvature, it will trace back. So the reflected rays are meeting at this point. This is a reflected ray, this is a reflected ray, so they are meeting at this point. So our image shall be formed at this point. Now here we can see the image is larger but real and inverted. So these are the four conditions. Let's understand two other conditions also. This is the mirror and this is the main axis. Now we have put our object at focus point. This is the focus point. Now what will happen? One ray parallel to the main axis, surely it will pass through the focus point only, as is the rule. And second ray, of course, from the center of curvature. If you see here, these two rays are parallel now. One ray passing through the focus point, second ray passing through the center of curvature. These two rays are parallel. So reflected rays are parallel. So the parallel rays will never meet. We'll say this will meet only at infinity. So when the object is placed at focus, the image shall be formed at infinity. And the last condition is when the object is between pole and focus. First ray, of course, will be parallel to the main axis and it will pass through focus point. Second ray, you'll find that it is passing through the center of curvature. Now this ray and this ray, you can find that the distance between the rays is increasing. So it will never, these rays will never meet. So the real image is not possible if the object is placed between F and P, between pole and focus, then the real image is never possible. So what will happen? Let us extend both the reflected rays and we'll find that these are appearing to be meeting at the back side of the mirror. So these are appearing to be meeting here. So we will have the virtual image at this point, right? So these are the 6 conditions for. After plane and concave mirror, let's see how the images are formed by a convex mirror. So there are 2 conditions. First is, let's say this is the convex mirror and this is center of curvature, this is focus and this is the pole. Let's assume first condition is that if the object is placed at infinity, this is the incident ray. We can see that after striking the reflecting surface of the mirror, the incident ray is diverging or it is spreading out. Similarly, the second incident ray also, which is parallel to the main axis, this is also getting diverging. Now, these two reflecting rays will never meet because they are diverging. It is going in this direction, it is going in this direction. So what to do? How to form the image? Let us extend both the incident rays. So if we extend this incident ray, then it shall be appearing to be passing through the focus. Similarly, this incident ray also appearing to be passing through focus. So they are appearing to be meeting at focus of convex mirror. So that means the image shall be forming at F, the size shall be point only, and it shall be virtual here and direct. In case of concave mirror, it was again position was at focus only, the size was also focus point, but it was real and inverted. Here in this case the nature is changed, it is virtual and erect. Second condition is if the object is placed between P and infinity. In this case, this is the ray, incident ray, parallel to the main axis. Again, it will be diverging and appear to be passing through focus point as was there before. And the second ray, which shall be passing through this point C, center of curvature, or rather shall be appearing to be going. It is appearing to be going towards the center of curvature. And then of course, if it is going towards the center of curvature, it will reflect back, it will trace back. So these two reflecting rays are appearing to be meeting here. This point is between P and F, and the size of the image here in this case shall be smaller than the object, and the image nature shall be virtual and erect. Right? So the usage of convex mirror, there are few usage mentioned here. One of course is the viewing mirror of the vehicle. On the side mirror of the cars or scooters are all having convex mirror. Then we use it in the blind turns, and for safety purposes we are using it. Wherever we have to make a smaller image, then we need to use the convex mirror. So in convex mirror we are making only the smaller images. Then there are certain formula for mirror. One of the most important formula is 1 upon V plus 1 upon U is equal to 1 upon F, where U is the distance between the pole and the object, pole of the mirror and the object. This is U. V is the distance of image from the pole. So if the image is formed here, then V is the distance between pole and image. And F of course is the focal length of the mirror. This is very, very important. 1 upon V plus 1 upon U is equal to 1 upon F. There is another formula which is for the magnification. This is M, we denote it by M. M is equal to H dash upon H. H dash is the height of the image and H is the height of the object, which again is equal to minus V upon U. So probably you don't have to mug it up. Once you start making doing the numericals, automatically this will be, you will be remembering it always. Now certain rules. Friends, the distance of object, image and focal distance should be taken with respect to pole. So in the numerical they will always say that the object is placed 30 centimeter from mirror. So we have to consider it that 30 centimeter from pole, and pole is the middle point of this mirror. So all the distances have to be taken from pole, number one. Number two, all the distances on the left hand side of the pole shall be negative. All the distances on the left hand side of the pole is negative. So we have seen so far that object is always on the left hand side. So the object dimension is going to be taken negative always. Then distance on the right hand side of the pole shall be positive. We have seen sometimes the image is formed on the right hand side. So in this condition we shall always take that dimension as positive. So example Gracia, in the figure distance from P to F and C shall be negative. P to F and C, because it is on the left side, it shall be negative. Then focal length of concave mirror shall always be negative. Focal length of concave mirror shall always be negative. We have seen it that the focal length was always here on the left hand side, so it will always be negative. Whereas the focal length of convex mirror was on the right hand side, so it shall always be positive. So focal length of convex mirror shall always be positive. And last is the height above the principal axis shall be positive. Above the principal axis, the height shall be positive. And wherever the image is formed on the lower side of the principal axis, that shall be taken negative. So all the height above the principal axis shall be positive. All the height below the principal axis shall be negative. So once again a revision: left hand side all dimensions are negative, right hand side all dimensions are positive. Focal length of concave mirror always negative, focal length of convex mirror always positive. Dimensions above the principal axis positive, dimensions below the principal axis are negative. Friends, let us solve few questions pertaining to mirrors. The first question is, which type of mirrors do the dentist use? The options are convex mirror, concave mirror, plane mirror and all. If you see the convex mirror, we have studied that convex mirror always makes diminished image. That means image which is smaller than the object. Whereas plane mirror always make virtual and image which is equal to the object. Dentists, they want to see the image larger than the object so that they can diagnose the problem better. And in concave mirror, if you are putting the object between focus and center of curvature, the image is going to be real and enlarged. So the dentist always use concave mirror. The next question is, give two usage each for concave mirror and convex mirror. So one use we have already seen above. One use is for the dentist. Second use of course can be for ophthalmist also. And for projectors also we can use the concave mirror, because the concave mirrors can converge the light rays to form a focused image, and this is what we need for projectors. So these two can be the examples for concave mirror. For convex mirror, one of the example is the vehicle side mirrors. As we said before also, the convex mirror, it always make diminished image, and in the vehicle when we are driving, when we see our side mirror, we want to see the vehicle coming from behind. So if the vehicle, bigger vehicle is coming, we want to see that vehicle. So a diminished image becomes in the side mirror and we can know what is coming from the back. So this is one usage. The second usage can be for the road safety. If there is a blind turn, for example, one road is coming this side, one road is coming this side, and we put the convex mirror here at the corner, then this convex mirror will have the image of vehicle coming from here and also vehicle coming from here. So the vehicle coming from both the side can see the convex mirror and know what is coming from the other side. So it is for the road safety also the convex mirrors are used. So you can see the concave mirror is dentist and projector, convex mirror, vehicle side mirror, and safety purpose on the road. The third question is, a concave mirror is making virtual, erect and enlarged image of an object. Please tell as to where the object would be located on the principal axis and make ray diagram also. So in concave mirror, there is only one position where the virtual image is made. That is when the object is placed between focus and pole, then the virtual, erect and enlarged image is formed. So the answer is that between pole and focus. The ray diagram, of course, we have found before also, that can be referred to. Then fourth question is, which mirror has widest field of view? Convex, plane, concave, and all have the same. These are the options. So as we have seen before also, while explaining the usage of convex mirror, the convex mirror has the widest field of view. So convex mirror is the answer. And last question on this slide. Make a ray diagram showing light rays parallel to the main axis falling on a convex mirror. Make angle of incidence and angle of reflection also. So there were only two conditions for the convex mirror. When the object is placed at the infinity, the incidence ray are parallel to the main axis and it is falling on the reflecting surface of the mirror and diverging. So we can make that, and we can make the angle of incidence and angle of reflection also by drawing the perpendicular first and then of course the angle. Let's solve few more questions. The first is, which signs are correct for showing an image forming below and above main axis respectively? So we have seen before that if the image is formed above the main axis, then it will be having plus sign, and if it is below the axis, then it will be having minus sign. So it is asking below and above the main axis respectively. So minus and plus shall be the answer. So minus plus. So D shall be the answer. Next question is, the height of an object is 4 centimeter. Then an object is placed at a distance of 15 centimeter from convex mirror, having focus distance as 10 centimeter. Find the nature and place of the image and what should be the height of the image. So what all is given? One, of course, the place of the object is given, that is U is given. U is 15 centimeter and U is always minus. So U is minus 15 centimeter. Then they have given the focus distance of the mirror as 10 centimeter. So F is 10 centimeter. Since it is convex mirror, so it will be positive. So F shall be plus 10 centimeter. Now let us apply the mirror formula. 1 upon F is equal to 1 upon V plus 1 upon U. That means 1 upon 10 is equal to 1 upon V plus 1 upon minus 15. If you solve this, then you will get V is equal to 6 centimeter plus. That means the image is formed on the right hand side of the mirror because it is plus. So the image will be forming on the right hand side. Then it says the height of the image and the nature of the image. Now we know the magnification formula, M is equal to minus V upon U. So minus V is how much? 6 upon U is 15. So 6 upon minus 15. So minus minus plus. So M will be 1 upon 2.5. That means the object or the image shall be 2.5 times lesser than the image. And of course, the convex mirror always make diminished image. So we can find the height 4 upon 2.5. So that is around 1.5 shall be the answer. Then make a ray diagram showing a convex mirror making a virtual image. So we can always make the ray diagram. We put the object between P and infinity, and we will find that the image is made between focus and pole, and definitely the virtual image will be made, and it will be diminished size. Here also it will be nature is virtual image. Na? Convex mirror always make virtual image. The next question is, a tangent is drawn on a point on a spherical mirror. A perpendicular is drawn from the point where the tangent touches the mirror. Where from the perpendicular pass? Very important. Friends, if you are drawing a perpendicular from a tangent on a circle, then it will always pass through its center. Always. So the answer shall be the center of curvature. Now let us solve 3 more questions. One is, a bus is 4 meters behind a car. If the center of curvature of side mirror of the car is 400 centimeter, then find place of image formation and its nature. Then also find as to how much diminished or enlarged the image shall be. So what all is given? U is given as 4 meters, and U shall always be minus. So U is minus 4 meters. Then the center of curvature is given as 400 meters. We know that focal length is half of center of curvature. So the focal length of the mirror shall be 400 upon 2, that is 200 centimeter. Now we have to have both these two either in meters or in centimeters. So let us have it in meters. This is U is minus 4 meters. So F is equal to 200 centimeters or 200 upon 100 equal to 2 meters. So F is now 2 meters and U is minus 4 meters. That is one. Second, always in the vehicle the mirror is convex. So the focal length shall be positive. So F shall be plus 2. Now apply the formula. 1 upon F is equal to 1 upon V plus 1 upon U. That is 1 upon 2 is equal to 1 upon V plus 1 upon minus 4. If you solve this, then we shall come to 4 upon 3 meters. That means, and the sign will be plus. That means the image shall be 4 upon 3 meters on the right hand side of the mirror. Right? So this is the place of the image, and it shall be virtual because it is convex. It shall be virtual. And how much diminished or enlarged the image shall be? We know that M is equal to minus V upon U. So V is 4 upon 3 and the U is minus 4. So minus 4 upon 3 and minus into 1 upon minus 4. So 4 will go and the M will be 1 upon 3. That means the image shall be 1 upon 3 times of the object. Right? Next question is, a person is standing 7 meters from a plane mirror. How much he will have to walk so that the distance between him and his image becomes 3 meters. Now, when the person is standing 7 meters from the plane mirror, at that time his image will also be forming 7 meters away from the plane mirror, the virtual image on the other side. So that means in this condition, the distance between his image and him is 7 plus 7, 14 meters. Right? But what we want? We want the distance between him and his image as 3 meters. So that means if the person is standing 1.5 meter away from the mirror, then his image shall also be 1.5 meter away from the mirror. That means the distance between the image and person will become 1.5 plus 1.5 equal to 3 meters. So we want this person to stand 1.5 meters away from mirror. Currently he is at 7 meters. So he will have to walk 7 meters minus 1.5, that is 5.5 meters towards mirror, so that the distance between him and his image shall become 3 meters. So answer shall be 5.5 meters towards mirror. And the last question is, what are the properties of light? We have studied it before. One of course is the light always travel in a straight line. Then second is the speed of the light is 3 into 10 to the power 8 meter per second. Then light travel as waves and particles. Another property is that if the light falls on opaque surface, then the image shall be formed on the backside, because light travels on the straight line. And the last was that we don't need any medium for light to travel. Light doesn't need any medium to travel, right? So this was some question and of course some details on mirror. In Hindi, of course, I have already posted this presentation. English I am posting now. If anyone has any doubt or questions, the person can contact me on the phone number and email ID given on the first slide. I shall keep on posting other presentations also for class 10th science students. Thank you.